Welcome back to eCoreAcademy students. My name is Anita and I am one of the teachers and co-founders here along with AJ, my younger brother. Today, as you can see, I'm bringing to you a new Algebra 2 lesson as we continue our venture into quadratics in Algebra 2 and higher level math. Today, we'll be continuing our quadratics applications mini-series. I've already done a video quadratic applications part 1 where we talk about different kinds of word problems. You will see quadratics are infamous for having a lot of applications and word problems. We ran through all the different scenarios. We even ran through one practice problem in the last video. Now in part 2, and I'm also going to be extending this into a part 3 so it's easier for you students to break these videos down and digest them in more bite-sized pieces as you take notes and learn alongside your peers and others. This video is going to be another practice problem, entirely a practice problem. I picked for this part 2 and part 3 two very difficult practice problems we'll be working through, and we're going to be doing it by hand. You can obviously do this on a calculator, and you can probably figure out how to do this on a calculator, but I'm going to be showing you how to do this by hand because for my assessments, we were required to do these problems by hand. So it's easiest to know how to do it by hand, then you can easily put these values into a calculator and figure it out on a calculator. So again, quadratic applications part 2. Let's do a practice problem together. This is going to be what I call number sense. So we're going to be given some details about some numbers, 2 numbers to be exact, and we're going to have to figure out what those numbers are. So that's going to be the whole theme of this quadratic application. Before I even get into the problem and the rest of this video, I'd really appreciate it if you paused and liked the video to show your support towards AJ and myself as curators here at eCoreAcademy. Also subscribe so you can join our expanding student community you don't want to miss out. Hit the post notification bell so you're notified of our latest posts. Drop a comment down below so we know what you think, your opinions, your suggestions, your questions, etc. And lastly, use our socials to share to those who could also benefit from eCoreAcademy. Without further ado, let's get right into the video I've planned for us today. Okay, so let's check out this problem about number sense. So number sense, here is the problem. So this sentence is going to pretty much sum up this entire problem for all of you. So here is the problem. Find 2 positive real numbers. So they have to be positive, they have to be real. Those are our 2 requirements. Whose sum is 90. So these 2 numbers added together have to equal 90, and whose product is a maximum. So one number times another number, the product has to be a maximum. So for example, if we're graphing a parabola, if we can represent these 2 numbers using a parabola, the vertex has to be a maximum. So if you look at 90 and you divide it into 2 numbers, if you separate it into 2 numbers when added together equal 90, those 2 numbers multiplied together have to give you the maximum product. So two positive real integers added together equal 90. The only restriction is these two numbers multiplied together have to have a maximum. We'll see exactly what all these terms mean as we go through the problem. As you solve this problem, please answer the following questions, and you'll see them appear. So first, we want to write a function to model this situation. So something that we can base this whole problem off of. We need to start somewhere with some kind of formula, some kind of understanding of the relationships between these values we're trying to find. So to do that, we're going to be writing a function first and foremost. Then we're going to be answering the question, what does the x-axis represent on the graph? Obviously, if we have a function, we can graph it on a coordinate plane. When we graph it, this question is asking the x-axis. Relative to this problem, what does the x-axis represent? What value does the x-axis represent? Does it represent the sum 90? Does it represent the product, which is a maximum? Does it represent one of the 2 positive real numbers? Or does it represent something else entirely? As we go through the problem, you'll understand what we're talking about. Next, what does the y-axis represent on the graph? So same thing. If the x-axis represents one thing, what does the y-axis represent? Next, what are the numbers? So after answering all these questions about the function, the representation of the x-axis, the representation of the y-axis, we want to really get down to the essential part of this question. What are the numbers? So what are these two numbers that we're talking about that are unknown, that have a sum of 90 and have a product which is a maximum? Lastly, we are being asked what is the maximum product. As you can see here, the only definite quantity we're given is that these two numbers added together is 90. We're only told that their product is a maximum, but we don't know what the product is. We need to find the two numbers and then multiply them together to find the product, and then we can check to see if that's a maximum. In this case, it's already given, it's going to be a maximum. So these are the 5 questions. These are the 5 parts of this essential question. Find two positive real numbers whose sum is 90 and whose product is a maximum. So let's get right into solving the first question. Write a function to model the situation. So the problem will appear at the top of the screen. So you remember the main idea of this video, which is find two positive real numbers whose sum is 90, whose product is a maximum. That will appear at the top of every screen for you to refer to. So we're going to be breaking these 5 questions into multiple parts. The first part, like I just said, we're going to be writing the function first. Let's start off with that. Here's the solution pre-written. I've written the question, write a function to model the situation, and here you already have the solution pre-written. So I do this with all my videos where I do a hands-on by hand solution where you can just pause the video, copy down my writing. So if you would rather copy it down in a notebook, and then on the next slide where I actually walk you through the problem, going through exactly what is written on the slide, then feel free to do that if it's easier for you to copy down and then listen. If not, you can just continue on to the next slide and follow along with me as I solve this problem. So I'll give you a second so you can pause the video and copy down everything that's written on the screen for my workout and my handwriting. Okay, hopefully that was enough time for you to pause. Let's go to the next slide. Okay, so we're going to be getting into our first question. As you can see, the problem appears at the top of the screen. Remember, it's the main idea, it's the whole purpose of this video. Although there are 5 different components to the problem, this is essentially the most important part of the problem. Find two positive real numbers whose sum is 90 and whose product is a maximum. So first, let's answer the first question I wrote on the previous screen. Write a function to model this situation. So we're going to be identifying the variables, we're going to be finding the relationships between the variables, and forming something cohesive. So we're putting words into numbers so that we can understand it and we can actually solve it mathematically. So I usually, in all of my videos, write the solution beforehand and put it on the screen for those of you who like to copy the solution down and then follow along with me on the next slide where I actually work through this whole solution. I do this during all of the problems I do by hand. So here's the solution pre-written for you. The only correction I have to make, because this is pre-written, I want to clarify that this 110 right here, this should actually be 90. So let me just cross that out and put 90 above it so you all are not confused. So 90. Yeah, so just make sure you get that as 90, because remember the sum is 90, not 110. For some reason I copied 110 down. So remember 90. So now that I've corrected it, you can copy this all down. I'll give you a second to pause the video so that you can do just that. If not, just wait for the pause and don't pause the video. Just continue on to the next slide. Okay, I hope that was ample time for you to copy that down. Let's go to the next slide. Again, problem at the top of the screen. We're going to be doing the solution together, and here is the first question. Write a function to model the situation. So first, what we want to do is we want to identify what we're trying to find. So there are 4 things that we know. We know that there are 2 positive real numbers. So the first positive real number, second positive real number. Then we have their sum, which is 90, which is the third. This is the third component we know. And then the fourth is that their product is a maximum. So these are the 4 key parts of this problem. So we need to name. So whatever we don't know, let's name. So we don't know the first positive real number. We don't know the second positive real number. We do know the sum is 90, but we don't know what the product, which is a maximum, is. So first, let's name these. Let's make them variables. Whatever we don't know, let's make it a variable so it's easier for us to write down, shorthand, understand. So First, let's identify the first positive real number. We're going to just call that x. So x is equal to the first number. So I'm just going to write that here. Again, we're just trying to name these, we're just trying to rename these terms as variables, so it's easier for us to write a function. Then we have our second positive real number. We can just call that y, because x and y in our mind, they complement each other. So y equals the second number. And then the next component that we want to mention is our sum. And remember, our sum is 90. So we don't really need a variable for this. I'm just going to write 90 equals the sum. We don't need to rewrite it as another variable. We already know the value is 90. So we're just going to say 90. Lastly, we have the product. So we're just going to call that P because product starts with P. So P is equal to, remember, maximum product. So maximum product. Now let's go about putting together what we know. So let's reread the problem at the top of the screen. Find two positive real numbers whose sum is 90. Okay, just stop there. Find two positive real numbers whose sum is 90. So remember, our first positive real number is x, second positive real number is y. So their sum, x plus y, is equal to 90. Remember, sum is addition. The first number plus the second number is equal to 90. So how can we write this mathematically? Well, we can write this as x, which is our first number, plus y, second number, equals 90. We've already been told that. Now, what we want to do is we want to rewrite this in terms of one of the variables. So what exactly does this mean? So we're going to be writing a second equation after this. We want to simplify this as much as possible. We don't know x and we don't know y. Therefore, if we rewrite it in terms of one of these variables, we can use substitution method and solve. Therefore, let's just, for the sake of this video, let's say we're going to rewrite this in terms of y. So we're finding what x is equal to in terms of y. Therefore, we're going to be subtracting y from both sides to get x by itself. So subtract y, subtract y. And therefore, if we subtract y from each side, we get x equals 90 minus y. Because x plus y minus y equals x. 90 minus y is just 90 minus y. So we get x equals 90 minus y. Now let's make our second equation. From the information we've been given at the top of the screen, we can make a second equation. And what is this? Well, we know that these two positive real numbers, x and y, when multiplied together, they have a product. And this product is p, which is our maximum product. So in other words, let me simplify it this way. X times y is equal to p. You can also rewrite this as p equals x times y. It's whichever way is easier for you to look at. So product is equal to our first number times our second number. Well, if you look at this, p is equal to x times y. Well, look over here. We know what x is equal to. X is equal to 90 minus y. We have an x in this equation as well. So what can we do? So we see x is equal to 90 minus y. We can take that 90 minus y and plug it into x in the second equation. So we can plug this in for this. Let me show you what I mean by rewriting this. So our product is equal to, instead of x, we're putting 90 minus y in. So 90 minus y. And then we just have our y. So now look how we've rewritten it in terms of y. So now instead of having px and y, we have p and y. We simplified it as much as possible by using substitution method. If we just simplify this further by distributing this y, we get p equals y times 90 is 90y. And then negative y times y is negative y squared. Therefore, we can say that our function, remember the original question at the screen is write a function to model this situation. Therefore, we can say the function that models this situation is p equals 90y minus y squared, which is the answer that we just got. So that is how you find a function to model the situation. If you need to, please pause the video and just go over how we found this. It's relatively simple if you break the problem down as much as possible. So again, the function that models the situation is p equals 90y minus y squared. Let's go to the next slide. So again, the main idea is at the top of the screen. So here is the problem. What does the x-axis represent on the graph? Remember, it was our second part of the question. What does the x-axis represent? Well, our x-axis, remember, is our horizontal axis. It is our independent variable. So what does it represent on this graph? Remember, our function is p equals 90y minus y squared. Well, what does it equal? What is it? So remember from the last slide where we said x is equal to our first number. Remember when we identified that variable x is equal to our first number, y is equal to our second number, 90 equals the sum, and then p is the maximum product. Because we have named our first unknown number as x, it has now become the x-coordinate of our solution pair. So if you were graphing this, or if you were using a graphing calculator and you were doing this using that calculator, you would end up, when you graph the function we just found, p equals 90y minus y squared, if you graph that and you found the vertex of the parabola after graphing it, the x-coordinate of that the x-coordinate of that vertex would be the first unknown number. So let's say you graph the parabola that represents this quadratic function of p equals 90y minus y squared, and you found that the vertex is something like, I'm just making this up off the top of my head, 50, the x-coordinate is 50, the y-coordinate is 5,000. Well, by reading that, you would know that the x-coordinate of the solution pair is your first unknown variable. The x-coordinate that I just mentioned was 50. Therefore, the x-coordinate is the first positive real number. So that is what the x-axis represents. The x-axis represents the value of that first positive real number. Therefore, the x represents our first number. Exactly what I just said. Okay, let's go to the next slide. Here is the same problem at the top of the screen. Here's our third question. What does the y-axis represent on the graph? Remember, your y-axis is your vertical axis. It is what we call your dependent variable. Well, what exactly does this represent? Now is when things kind of get a little bit confusing, so stick with me. Although the second number is what we're calling y, remember x is equal to our first number, y is equal to our second number, 90 equals our sum, and p is our maximum product. Although we're calling that second number y, when we graph, the maximum is the value of the function, so the value of the maximum is represented. What does this mean? Like I just said, although we're calling that second number y, it is the y-axis does not represent the second number. Let me say that again. Although we're calling that second positive real number y, the y-axis does not represent that number. Although the x-axis represents the first positive real number, the y-axis does not represent the second positive real number. Let me explain why. When we take that quadratic function, p equals 90y minus y squared, and we put it into proper quadratic form that the calculator could understand, we would just rewrite that as p equals 90y minus y squared as y equals 90x minus x squared, just so the calculator can understand it. Then when we graph that, we will get a parabola because it is a quadratic function. The vertex of that parabola is a maximum. So the parabola looks something like this. The vertex, which is a maximum, is our solution. And if you use the maximum function, if you use the functions of the calculator and find the maximum, which is the vertex of that graph, you will get a coordinate pair. Like we said, the x-coordinate represents our first number. However, the y-coordinate represents your maximum product. Because if you think about it, x is what you're putting into a function. It's your input. Y is what you're getting out of the function. From our function p equals 90y minus y squared, we're putting a value in and we're getting a value out. Our output is going to be our y-coordinate, which is our y-axis. Because this function is p equals, p is our maximum product. Therefore, the output, which is the value of the function at that given point, is the maximum product. Therefore, the maximum is the value of the function at the vertex. So the value of the maximum is represented. Therefore, the y-axis represents your maximum product. Everything I just explained, that's the reasoning to how you get there. Therefore, the y-axis represents our maximum product. So x-axis represents our first unknown variable. The y-axis represents our maximum product. Please keep that in mind, and you will not get confused if you just try to reason and you rewatch this and you even come up with your own reasoning for it. But that's the best I could do. Again, y-axis represents maximum product. Now let's go to fourth and I believe fifth. Yes, fourth and fifth question. We're going to be doing these together. So what are the numbers? That's our first question. That's the main idea of this whole video. What is the maximum product? Remember, the maximum product is unknown. We know the sum, but we don't know the maximum product. Here's the solution pre-written. If you want to pause the video and copy it down. So we're putting everything together now. We're putting together what we found in the first part by writing a function, the second part by identifying what the x-axis represents, and the third part identifying what the y-axis represents. Putting it all together, and we are finding what the numbers are, what the numbers x and y are, and then what p, which is our maximum product, is equal to. So if you want to take a pause and copy this down, please feel free to do so. Okay, hopefully that was enough time. So now let's move on to the solution. On the next slide, I'll work it out with you. So first, let's rewrite 90y, p equals 90y minus y squared. Let's rewrite that so our squared term comes before the 90y. So I'm just gonna write at the top of this space. So first, let's rewrite p equals 90y minus y squared as p equals negative y squared plus 90y. Okay, so you don't need to really do that on a calculator if you were graphing this to find the solution. However, because we're doing this by hand just for neatness and organization, I would prefer to do that. Put it in a form that's easier for you to look at and understand. By looking at this, you can actually compare it to standard form. So I want you to look at how I'm going to do this and compare it to standard form. So here's standard form for you. Those of you who should not have forgotten, here's standard form rewritten. Standard form, which is y equals ax squared plus bx plus c. So I want you to compare whatever we have, p equals negative y squared plus 90y to y equals ax squared plus bx plus c, which you should be familiar with. Well, it's not exactly standard form, but we can compare it to standard form. We don't have a c value, so we have negative y squared plus 90y plus, but we don't have anything after the 90y. Therefore, we can just assume that the c value is 0. We would write it as negative y squared plus 90y plus 0, but it's just not necessary. So the 0 has been omitted. Just assume it's a 0. The c value has been omitted, so just assume it's 0. However, we do have a value. We do have a b value. So if you look closely, you'll be able to tell the a value is the constant that comes right before your squared term. Here, before the y squared, we have a negative sign. So if there's a negative sign, we automatically assume it's negative 1. Just as if there's no constant whatsoever, we immediately assume that a is equal to 1. If there's a negative sign without any constant, we assume it's negative 1. In this case, a is equal to negative 1. Also, we can look at our b value. Our b value is more straightforward. It's 90 because it's just the constant that comes before the one that comes before. It's just the constant that comes before just the x value or the variable to the power of 1. In this case, it's just 90. So that should have been pretty straightforward for all of you. So you might be wondering, why is this information important? Remember how I said that your maximum was actually which is your vertex of this parabola, of this quadratic function. If you graph this quadratic function, you found the parabola, that maximum, which is the vertex, has 2 of your answers. So the 3 things we're trying to find are your first number, your second number, and your maximum product. Remember how I said on the previous slide that the x-coordinate of the vertex is going to be equal to your first number, the y-coordinate of the vertex is going to be equal to your maximum product, and with these two values, you can figure out what your second number is. Therefore, we need to find what the vertex of this what the vertex of this quadratic function is. So let's do that here. I'm just going to draw an arrow over here. So we need to find the coordinate of the vertex because that has two of our three answers. And using those two answers, we can find the third one because we've been given enough information. So coordinate of the vertex. Remember, it's the coordinate of the vertex is, so first we need to find the x-coordinate. So in order to do that, remember we have x equals negative b over 2a. So in vertex form of a quadratic function, it's easy for us to see because it's just hk. However, in standard form, to find the x-coordinate, we need to take the b term, multiply it times -1, and then divide it by 2 times a. Remember that. Hopefully you remember that. Then we will find the x-coordinate of the vertex, and we can take the x-coordinate and plug it back into our quadratic function to find out what the y-coordinate is. So let's find the x-coordinate. X is equal to negative b over 2a. And as you can see, we know what the b and the a value are. So we can say negative 90 because b is equal to 90 over 2 times -1. Then we can just do negative 90 over 2 times -1 is -2. And lastly, negative 90 divided by -2 is positive 45. So that's just how you work it out. So our x-coordinate, now we know our x-coordinate is 45. Our x-coordinate is our first number. Therefore, our first number is equal to 45. And here's a shortcut that I don't know how many of you thought of, but let me just mention it. So we know that our first number plus our second number is 90. X plus y equals 90. Well, now we know what our x is. Our x is 45. Therefore, we can find out what our y value is. Our y value, remember, was our second number. So I'm going to write here y is equal to our sum, which is 90, minus 45, which is our first number. And that is equal to 45. So remember, the first number plus the second number have to equal 90. Therefore, we just reversed it and we said that 90, which is our sum, minus the first number, which is 45, should give us our second number, which is y, which is also 45. Therefore, how do I answer this first question? What are the numbers? Well, the numbers are they're both the same number, are 45 and 45. So our first positive real number is 45, second positive real number is 45, and they're both positive real numbers. So that's solved. So 45 and 45 are the answers to that first question. Well, what is their maximum product? Remember, their maximum product is p. So p is equal to, well, we could refer back to that negative y squared plus 90. We can do p equals negative y squared plus 90y, but in actuality, we don't need to do that because we know that the maximum product is equal to the first number times the second number. Rather than plugging 45 into that quadratic function and having to square it and then do that times -1 and then doing all that math, we can just multiply 45 times 45. So 45 times 45. If you want to do it by hand, just do it off to the side, but I already have the answer for you just to save time, and that is equal to 2025. So to answer the question, what is the maximum product? 2025, and that's a shortcut. So just use reasoning and logic, and you'll be able to do a shortcut. You don't need to plug 45 back into p equals negative y squared plus 90y. Just multiply your first number, which is 45, times your second number, which is 45. You'll get the answer, which is, again, 2025. So that is the whole problem that we just solved together. First question, this is a quick recap. First question was on writing the function. Second question was on what the x-axis represented. Third question was on what the y-axis represented. Fourth question, what were the actual two numbers. Fifth question was, what is the maximum product of these two numbers? And we just solved all of that in this video. So that for you was number sense with quadratic applications, and I hope it was helpful. If you like this video, please not pause, but finish the video, then like it, and also subscribe so that you can join our student community. We would really appreciate it if you also hit the post notification bell so you're notified of our latest posts. Don't feel afraid to drop a comment down below because we love to hear what you all think. And lastly, please use our socials in the description box below to share eCoreAcademy with those who could benefit. We're trying to do goodwill for the community, so by spreading the word about eCoreAcademy, you are doing goodwill for the community as well. Lastly, if you have any business or personal correspondences, please reach out to us using our Gmail, eCoreAcademy@gmail.com. And lastly, we have a website coming out very soon. The link is up here. It'll be it's up now, but we're gonna be doing a whole tutorial on it, and we'll be posting a video on our channel about the website itself, running you through the website. But it has so many sweet functionalities for all of you students, including exclusive notes from myself and AJ, including self-evaluation quizzes, including whole courses organized for you all based off of how AJ and I took them. So it's easiest for you to just follow through and go through them. And if you're doing a course in school, to complement that with our eCoreAcademy materials, or if you're studying over the summer or reviewing or whatever it is, it'll be organized and it'll all be ready for you to use to help you grow to your greatest potential in each of these subject areas. So please check that out when that comes out. We will be notifying you so you won't miss out. All right, that's all I have for you today. Please look out for part 3, which we'll be talking about area. It's a pretty difficult problem. I hope you all are ready to tackle that with me. Have a great day. See you next time.